Hello, Math Humans. We're going to do 2.4 today. We're going to be talking about the normal distribution. We actually started this conversation a little bit yesterday. So we're going to look more thoroughly at the normal curve, the empirical rule, z-scores, and then a 5-number summary of the normal distribution. Before we get started, though, I want to go back and remember the formula for standard deviation. So I'm going to write sample standard deviation. And remember that when we did it by hand, S was equal to the square root of, and we did the sum of all of the x minus x bars, and then we squared it, and we did all of this in a table, and then we divide by n minus 1 and take the square root. So just so you remember, x minus x bar is the distance a data point is away from the mean, and that's your x bar. And then to make everything positive, we did x minus x bar squared, and that just makes everything positive. Okay, the square root, well, if I squared everything to make everything positive, then I have to take the square root because this undoes the square, and then I have my S. And then we learned how to use our graphers, and then angels started singing hallelujah because it makes your life so much easier. So today we actually want to look at the characteristics. Let me get another piece of paper since I scribbled all over this one. We want to look at the characteristics of the normal distribution. So if we go ahead and sketch that. So remember, it looks something like this, and we'll try to pretend I can draw a nice graph. Okay. Remember, this is the exact middle, and this is your x bar, which is the average. And remember, we get the average by summing all of the individual x's and then dividing by how many of them there are. So there's features about the normal curve that we want to look at. The first one, and I alluded to it a little bit yesterday, is that if I have a -1 and a +1 standard deviation, well, the thing that I want to add today is that this comprises about 68% of the data. So for most normal curves, within one standard deviation is going to be approximately 68% of the data. And that's going to be in that area right there. So in case you can't see that, so plus or minus 1 standard deviation is going to be about 68% of the data. Well, then we go out to 2 standard deviations, and I guess my picture's a little bit crappy, so sorry. And then if we add those, and I'm going to do these lines going this way, now that's going to comprise about 95% of the data. So that says that plus or minus 2 standard deviations is going to equal about 95% of all of the individual data points. And then if we come out here to 3 standard deviations, okay, so let me color that in, okay, that's going to be approximately 99.7% of the data points. So plus or minus 3 standard deviations is going to be 99.7% of the data. And then anything that's outside 3 standard deviations, so greater than the 3 standard deviations, is basically going to be considered an outlier. Okay? All right. So let me formalize this. This is called the empirical rule, and it is talking about the characteristics of our normal curve. So it says that 68% of the data are going to be within plus or minus 1 standard deviation of the mean. And remember, that's x bar. Okay? The next statistic was 95% of the data are within plus or minus 2 standard deviations of the mean. And then our last one for the empirical rule was 99.7% of the data are within plus or minus 3 standard deviations of the mean, which is x bar. Okay, so it only works for a bell-shaped curve. Oops, only works for a bell-shaped curve. If the curve is any different, if it's shaped differently, then the empirical rule is not going to apply. Okay. Other couple of things just to remember from the work that we did yesterday. S is going to equal our sample standard deviation. And sigma, mine always looks stupid, is the population standard deviation. And almost all of our calculations are going to be on a sample because it's really hard to come up with a population information. All right, so let's talk about our first example. So I've already got it written out just to save us a little bit of time. And it says a survey finds that the prices paid for a 2-year-old Ford Fusion are $10,500 with a standard deviation of 500. So a sample of 10,000 people bought 2-year-old Ford Fusion. So then we have a series of questions. So question A says, how many people paid between 10,000 and 11,000? And then how many people paid less than 10,000? And how many people paid more than 12? So I'm going to start doing the problem by drawing our bell curve and putting in our information. So we know that the price that they paid is going to be the 10,500, and that one standard deviation is going to be 500. Okay, and so that would put us at, I'll put it up here, 11,000, and that's one standard deviation. Two standard deviations is going to be 2,500, so that's going to be 1,000, and that's our two standard deviations. So that would be 11,500, and then our three standard deviations would be 1,500, and that's going to be our third standard deviation, and that's going to be out here at 12,000. Okay, and so then I would do the same. I would subtract 500, so this one's going to be at 10,000. This one's going to be at 9,500, and then this one's going to be at 9,000. And this is two standard deviations and three standard deviations. So there's kind of our normal curve. So when I start working on A, it says how many people are between 10 and 11,000. So if you notice, let me use some colors. Here's one standard deviation. So here's 10,000 and 11,000. So that is one standard deviation. So based on the empirical rule, that's 68%. Well, if I multiply 0.68 times the number of people that we surveyed, which was 10,000, I'm going to get that 6,800 buyers. Okay, so then I would write my answer well. So I'm going to 6,800 buyers paid between 10,000 and 11,000. So again, that information is coming from our normal curve because there's those numbers right there. And that was 68%, one standard deviation. So for B, B says how many people paid less than 10,000. So if this is 10,000, they want to know how many people paid less than 10,000. So I'm going to do the math this way. 68% paid between 10 and 11,000. Okay, so that means that 32% paid either more than or less than the $10,000. Okay, oops, I forgot a 0. Alrighty, so 32% paid less. Okay, so 32% means that it's all of these people going this way and all of these people going that way, but I only want those that made less than 10,000. So if I take the 32% and I divide it by 2, I get 16%. So 16% are going to pay more than 11,000, and 16% are going to pay less than 10,000. Okay? So then I do 0.16 times the total number of people that I had, and I get 1,600. And then I'm going to write my answer well. So I'm going to say 1,600 buyers spent less than $10,000. Okay? All right. So again, let's just talk about where that 16% came from. 68% is within one standard deviation. That means that everybody else outside that is 32%, because these two numbers added together is 100. But 32% includes both these guys and these guys, and I'm only interested for part B, these that are less, so that's half of 32, which is the 16%. And then I multiply the 0.6 times the 10,000 to get 1,600. Okay? Now let's do part C. So on C, C says how many people paid more than 12,000? So 12,000 is out here. Okay? So that's right at our 3 standard deviations. So remember that 3 standard deviations includes 99.7% of the data. So that means that everything in here includes 99.7%. But I want outside of that, so if I take my 100% and I subtract the 99.7, I get 0.3%. So now I can take this 0.3 and I can multiply it by my 10,000, which is the number of people that there were. But 0.3% is the same thing as 0.3 divided by 100, which is 0.003. So you have to be really careful with your percentages. Okay, so 0.3% is the same thing as 0.003. And then I only want the top half, so I'm going to divide that by 2 to get 0.0015. Okay, just like we did in this one, where I took half of the percentage, because I'm only interested in the top half of the data. I don't want the bottom half. So now if I have my 0.0015, so 0.0015 times the 10,000 people that bought cars, and you're going to get 15 poor schmucks paid more than 3 standard deviations. So paid more than $12,000, okay? And those are the poor schmucks that didn't remember what it means to talk about standard deviations, okay? All right. So now the next thing that we want to talk about is z-scores. They're actually really easy to calculate. So a z-score talks about how many standard deviations a number is away from the mean. Alrighty, so if I wanted to calculate a z-score, it's going to be x, which is our data point, minus the mean divided by s. So it is the data point minus the mean divided by the standard deviation. Okay? Typically, for a z-score, we want our z-scores to be between 2 standard deviations. Okay, so this would be a good z-score. If z is greater than 2 or z is less than a negative 2, then this would be considered, in this particular book, they call it an unusual, S-U-A-L, which means that it's going to be outside the two standard deviations. Okay? Alrighty, so a z-score is talking about how many standard deviations a number is away from the mean. Typically, a good z-score is to be less than 2 or greater than a negative 2 because that means it's 2 standard deviations away from the mean. Greater than that means that the z-score is bad. All right, so I have our next example written out, which is lovely. Okay, so this one says a class took a test with a mean of 75%. So remember that means that the average was a 75%. And it had a standard deviation of 5%. So we know that S is equal to 5%. We have to be told that the test scores follow a normal distribution. So the first part says if a student earned an 87% on the test, what's the student's z-score, and then what does it mean? And then on the next one, if a student earned 73% on the test, what is their z-score and what does it mean? And this one is the opposite direction. If a student has a z-score of 1.43, what actual score did they earn? So we'll take these one at a time. So for A, we know that the mean is a 75% because we were told that in the problem. We also know that the standard deviation is 5. So in the first part, we know that X is an 87%. So the z-score is going to equal X minus X bar divided by 5. So here's the 87. Subtract the 75. Divide by, that's an S by the way, not a 5, by 5, and I get 2.4. So that means that the student score, so I'm going to write that the z-score is 2.4, and what that means is that the student's score is unusual, yay for them, and it means that it is greater than 2 standard deviations away from the mean. Okay, so hopefully you have the problem written down because I'm going to have to go to a different sheet of paper. Okay, alrighty. And so if you think about our normal curve, remember, this was the 68%, and then out here, this is the 95%, and then out here is that's 2 standard deviations in 1. And you can't see the cool picture that I'm drawing, sad day. So that means that the student's score is above that 95%. It's above the second standard deviation. So that means also that their score is in the third standard deviation, okay? Just so it's saying it's between the second and the third, okay? All right, so then if we move on and we do part B, so B said a student earned a 73 on the test, so X is equal to 73. Remember that the X bar was 75 and the standard deviation was 5. Our Z is equal to X minus X bar divided by S, so it's 73 minus 75 divided by 5, and I get a negative 0.40. So if you think about this, the z-score, so if this is my normal curve, this is a -1 standard deviation, and this is a 1 standard deviation, that guy's score is in that particular area. So the z is a negative 0.40, and the student is within 1 standard deviation of the mean. So it means that they were really close to the average, okay? And so just to think about, that's within that 68% of the data points, okay? Part C says a student had a z-score. Bring my computer back. I hate it when that happens. The student had a z-score of 1.43, and what's their score? Okay, so let's write down what we know. We know that x bar is 75. We know that the standard deviation is 5. We know that z is 1.43, and we want to know what's x. So then remember the formula for z is x minus x bar divided by s, so I'm going to write in what I know. So I have 1.43 is equal to x minus 75 over 5. I need to cross multiply, so 5 times 1.43 is equal to x minus 75. I need to take the 75 to the other side of the equation, so x is 5 times 1.43 plus 75, and that is 82.15. So the student's test score was an 82.15%. So sometimes we can go the opposite direction. Alrighty, I have one last thing for us to talk about, and that is the 5-number summary for normal distribution. So a little bit different than our other 5-number summary. IONS. Whew, writing is extra. All right, so for the 5-number summary for a normal distribution, we're going to know that the minimum is going to be equal to x bar minus 3 standard deviations. Q1 is going to equal x bar minus that 68% times the standard deviation. Q2 is going to equal x bar. Q3 is going to be x plus that 0.68 times the standard deviation. And then the maximum is going to be x bar plus 3 standard deviations. Okay? I have one last example for us. And we're going to do the example that we just did. So we're going to know that x bar was 75%, and our standard deviation was 5%, and so I want to find the 5-number summary. Okay, so then I'm going to use my handy-dandy formulas. So the minimum is equal to x bar minus 3 standard deviations, so it's 75 minus 3 times 5. 75 minus 15 is 60, okay? And that's going to be a percent because these are going to all have the same units. My Q1 is x bar minus 0.68 times s, so it's 75 minus 0.68 times 5 because that's our standard deviation. And I'm going to get 71.6%. My x bar is given, which is really nice. And then my Q3 is going to be 75 plus 0.68 times s. So that's going to be 75 plus 0.68 times 5. And that's going to be 78.4%. And then my last one, my maximum, is x bar plus 3 standard deviations, so it's 75 plus 3 times 5, and that's going to equal a 90%. So what this tells us is the lowest score on the test was a 60%. The highest score on the test was a 90%. The average was a 75, and then these were my 2 quartiles. Alrighty. Whew, that was a long one today. Thanks for being patient, and I'll see you soon.